Welcome to the Board for Certification of Nutrition Specialists educational webinar series. The BCNS, in partnership with the American Nutrition Association, is very pleased to be hosting this Nutrition Pro educational series webinar. The BCNS fosters human health by setting and overseeing the highest science-based standards for nutrition professionals. The Certified Nutrition Specialist certification is the gold standard credential for advanced clinical nutrition professionals, and the Certified Nutrition Specialist Scholar certification recognizes advanced knowledge, scholarly work, and experience in the field of nutrition in the areas of research, academia, or industry. We encourage all of you listening to visit our website at nutritionspecialists.org for an abundance of nutrition information, resources, and upcoming webinars. Thank you and enjoy the presentation.
Thank you all for being here. Today we're going to talk about understanding diabetes and the link between diabetes and Alzheimer's, which is really some very brand new breakthrough research. And before we get started, this is one of the most important topics we can talk about. But I want to warn you ahead of time that there might be moments during today's talk where you feel like this, or you feel like you just want to run for the exit, because some of this is intense information, but it's extremely important, and there's a lot of good news here. Some of it is a little bit scary, and that's understandable, but at the end of this, there's some really positive news from all of this, really, really exciting positive news. So if you have the urge to run out, please wait for the end. There's very good news here. Okay, so we'll start light. Diabetes has been around for a very long time. The first time it was ever diagnosed was way back in 1500 BCE. A group of physicians noticed that people had a condition in which basically when they would go to the bathroom and urinate, ants would swarm the urine. They had no idea what was going on, but that was the first time written down that we have any understanding of diabetes. All the way back 1500 BCE until basically the 1920s and really the 1940s, there was no effective treatment for diabetes whatsoever. We've really come a long way, and that's a big point for today, is that we really have this condition in many ways very much under control, but we're learning a tremendous amount about it, and a lot of this information needs to get out. So what percentage of the US population do you think has diabetes? What's your guess?
30%. 25, 30%.
Okay, so 12 to 15% of people have diabetes. It's about 30 million people. But what about pre-diabetes, which we're going to talk a lot about today? First of all, what is pre-diabetes? What does that mean?
High sugar.
It means that somebody is on their way to developing diabetes. That there is more sugar in their blood, which we'll talk a lot about, than there should be. It's a warning that they're on their way to developing diabetes. How many people do you think in the US have pre-diabetes? It's about 38%. 89 million Americans have pre-diabetes. Here's the startling part. 90% of them don't know that they have it. We're going to talk more and more today about what that means, though, and how critical it is for people to know they have pre-diabetes. That's one of the most important points of today. Half of the US population has either diabetes or pre-diabetes. 1 in every 2 people. Why is understanding diabetes so important? For the obvious reasons that it has a very significant personal toll on people if it's not treated. Everything from damage to the eyes, the kidneys, the nerves. It can increase the risk of developing a heart attack, a stroke, removing a limb. One of the key things we've really learned this year, though, is the link between diabetes and Alzheimer's and dementia, which we'll talk a lot about. Also, there's an economic toll. There's a concern that if we don't get a handle on diabetes and prediabetes, it could bankrupt our country. The international spending for diabetes is estimated to rise to $802 billion by the year 2040 if we don't do something about it. Okay, so the plan for today, talk about the latest understanding of diabetes, really understand what's going on, what can be done now, and talk about this link to Alzheimer's disease. Okay, so what is diabetes? If we had to sum it up in a sentence, diabetes is a disease in which blood sugar is too high. Too much sugar in the blood. What do we mean by blood sugar? What we mean by that is the food that we eat, much of it has sugar in it. If we were to break it down into little pieces, it's filled with sugar. Sugar, though, is the main source of fuel for our brain and our bodies. We absolutely need sugar. There's a lot of talk about how bad sugar is for us, but the truth is we wouldn't be able to do anything if we didn't have sugar moving our muscles and making our brain run. What do you feel like when you're hungry? And how do you think when you're hungry? You have a very hard time. Because without sugar, when our sugar levels drop, we really can't think clearly. We have a very hard time even getting the simplest thing done. But the key thing is that sugar has to be in the right place in our body. That's the key point. And the right amount. We want the sugar to be in our muscles and in our organs, not in our blood. Okay, so what we mean by that is if you look at this image, this is if you took a blood vessel and you looked inside. There is sugar running through our blood vessels, but we want to get it delivered into our muscles or into our organs. The blood vessels are just carrying the sugar. So how does the sugar get into the muscles from the blood? Anybody know how that works? Okay, so what happens is if we zoom in on a muscle, it's actually made of a lot of different cells. So this is one cell right here. And so we're going to ask this question, how does sugar, like this little pink dot, actually get into a muscle cell? The answer is insulin. What happens is insulin knocks on the doors of your cells and basically says, let the sugar in. It's almost as if it's a secret knock. What's happening here is this. If this is one of your muscle cells, the sugar is outside in the blood and needs to get inside the muscle cells. It cannot get in on its own. This is a regulated process. So what happens is insulin is released into your blood. The insulin attaches to the muscle cell, essentially knocks on the door, and then magically a little tunnel opens up in the cell, lets the sugar inside the muscle. Without the insulin, what happens? The sugar can't what? Get inside. Okay, one way to think about diabetes, and I do not want to make light of it, this is very serious, but just to bring this point home, have you ever been waiting for a table at a restaurant? And you're in the waiting room, or you're in the lobby, and you're waiting and waiting and waiting, and you finally get into the restaurant, you're with a bunch of people, you finally get in, and there's one guy sitting there, right? A ton of empty tables. Why is that? Something very inefficient is going on. That's essentially what happens in diabetes. There's lots of sugar in the blood, it's just not getting into the muscles. If we extend this out, the hostess or the host is the insulin, and they're not bringing the sugar in to the right place. Okay, so in diabetes, the big message is the sugar's in the blood, but it needs to be in the muscle cells. If the sugar is trapped in the blood vessels, it starts destroying those vessels if there's too much there. And that's why people lose limbs or they lose their vision. The sugar can't be trapped in the vessels. It starts tearing those vessels apart. Okay, so let's take a step back and kind of put this all together as we build this foundation. What happens is normally you eat. Your food is digested initially in your mouth, it then goes down your esophagus, into your stomach. Your body amazingly knows that you've eaten, and your pancreas starts to release that insulin. So your pancreas releases the insulin into the blood, and it allows that sugar that's coming from the food to get into your muscles and to get into your cells so you can lift things up, so you can move around, so that you can think. Okay, why do blood sugar levels drop after insulin release? Because the sugar is now where? It's in the muscles. Very good. Okay, next question. Where is your pancreas? Right side, behind your stomach. It's behind your stomach, and it's actually protected by the ribs in your back. It's actually not in the front, it's in the back here. Okay, so what is insulin resistance? Has anybody heard about insulin resistance? That's a key part of this process and a key problem that takes place. We said that insulin knocks on the doors of the cells, lets the sugar in. Insulin resistance is that the cells can't hear the knocking. That the insulin is knocking on the cell doesn't hear it, doesn't let the sugar in. The sugar is trapped in the blood. What do you think the body does next? That's a good answer. What happens next? What would happen if you were knocking on the door and nobody let you in? What would you do?
I'd call them.
You'd probably first knock louder, right? Start banging on the door. That's exactly what your body does. And that's a key part of this. And that's a key thing that we have to think about. Your body is always trying to help you out and make up for things that are going wrong. And because of this, this is why people don't know they have prediabetes, is that when the cells are not hearing the knocking, the pancreas knocks louder. It releases more insulin into the system. It works double time, overtime, and keeps releasing more and more insulin into the system to allow those cells to open up and let the sugar in, which is great in the short term because your body is helping you and you have an individual would have no idea that anything is wrong. Your body's covering something, a flaw that's taking place. Okay, eventually though, what happens? You have to knock what? Louder and louder. The cells essentially get deafer and deafer. They lose the ability. And eventually, the pancreas does what? It quits. It can't keep up anymore. It gets exhausted. And then you have a situation where the cells are not letting the sugar in, and the body is not able to produce the right amount of insulin. That is essentially insulin resistance. Okay, so what we're talking about with insulin resistance is mostly type 2 diabetes. So there's different types of diabetes. Why are we focusing, though, on type 2? What are the reasons? 90% of all diabetes is type 2 diabetes. What's happening in type 2 diabetes is the cells don't hear the knocking. That's part of it. The other part is that the pancreas itself is not releasing enough insulin. So these two things together, not loud enough knocking, not enough knocking. Does that make sense? And that leads to type 2 diabetes, where there is too much sugar left in the blood. Okay, what is type 1 diabetes? That accounts for 10%. Very serious, very important as well. Everything we've talked about in terms of sugar not being able to get into the muscle cells absolutely applies. But in type 1 diabetes, we really don't see the problem with the knocking and the cells not hearing it. Instead, what we see is the pancreas itself is damaged. So how does the pancreas get damaged? What can happen? Why would somebody develop type 1 diabetes in which the pancreas doesn't make any insulin, and then what happens is you can't knock on the cell's door and let that sugar in? So why would that happen?
Genetic mutation.
Genetic mutation could be. Cancer. Somebody has pancreatic cancer and the pancreas stops working. Another key insight, though, is that in some cases it's an autoimmune issue, is that the individual's own immune system starts to attack the pancreas as if it's a virus or a bacteria and essentially destroys the pancreas's ability to release insulin. Okay, very different type 1 and type 2 in the initial stages, but both of them conditions have the problem of too much sugar in the blood because it's not getting into the muscles. Okay.
So how did they know which is which? What test did they know?
So there's different, we'll talk all about that. There's different tests that they can do depending upon, if you're not releasing any insulin, you would have type 1 diabetes. No insulin at all, right? Okay, myth or fact? Okay, soda increases the risk of type 2 diabetes. Is that really true? Can we say that scientifically? Okay. Drinking just 1 can of non-diet soda a day raises the risk of developing type 2 diabetes by 22%. Just recently published. 22% increased risk. Why is this? What is happening? So it's essentially like a sugar bomb that's being released into our system that our body doesn't really know how to deal with over the long term, and it's overwhelming our system, and the insulin has to keep up, right? So that can happen in some cases. Let's put this in perspective. How much sugar is in 1 can of soda? What do you think? About 44 grams, about 9 teaspoons of sugar in a can of soda.
What about diet?
So we'll talk all about diet at the end. So is that more or less than the American Heart Association recommends a person should have in 1 day? So it is actually a little bit less, but not by much. 1 can of soda is a little bit less. So the American Heart Association says that men should have about 7 to 8 teaspoons of added sugar. That's a key point. And women should have about 5 to 6 teaspoons of added sugar a day. So almost there with just 1 can of Coke. We will come back to that in much greater detail. But let me ask you this question now. Is diabetes genetic?
Yes.
Does that mean that if somebody inherits a gene, that they're definitely going to get diabetes? Okay, so the studies that have come out, and what our understanding of this comes from twins. If we look at twins, they are identical twins. They are carbon copies of each other. They are clones, identical, exactly the same. So we would think that if the disease is entirely genetic, it's based upon the genes, that if one twin gets the disease, what would happen to the other one? They would get the disease when? If it's entirely genetic, it would be every time. Every set of identical twins would have the same diseases. Do we see that in diabetes? So we do not see that in diabetes. What we see is that when one twin has type 1 diabetes, where the body doesn't make any insulin at all, the other twin has about a 50% chance of developing it. With type 2 diabetes, it's about 75%. One twin has type 2 diabetes, it's about a 75% chance the other one will have it. What does that mean? What does that tell us?
Environmental.
It's not all genes. Genes definitely play a part, something very important.
Behavior.
But our environment, our lifestyle, does also play a big part. Just because we inherit the genes doesn't mean we're going to get the condition when it comes to diabetes. Pretty much every common disease works the same way. Okay, we will discuss treatments and prevention in much more detail. But first, I just want to take a bit of a left turn and talk about the brain and this really new, very fascinating research that links diabetes to the brain. Okay, so does having diabetes increase the risk of developing Alzheimer's disease? Okay. Diabetes increases a person's risk of developing Alzheimer's by 65%. It is basically, besides age, the number one risk factor is diabetes. It's now thought that a considerable percentage of Alzheimer's disease at its root is diabetes that wasn't treated effectively. So why is this happening? So we need to take a step back. And in the series that's coming up, we're going to talk all about Alzheimer's. We'll cover this in about a minute or two. We need to understand Alzheimer's at a certain level. So what is Alzheimer's disease? What happens in the brain? And how could possibly two things that seem so different, how are we understanding that they're very much linked together? So Alzheimer's, we have to think of our brain like this. Your brain is about 3 pounds. If we were to zoom in, it's made of these brain cells. This is 3 of them. You have how many? 100 billion. Your 100 billion brain cells talking to each other, communicating with each other, is your feelings, your thoughts, how you move. Everything is based upon 100 billion brain cells that look like that, communicating and talking. Alzheimer's is basically trash in the brain. What that means is that something accumulates in between those brain cells so they can't communicate with each other. Basically, if I was trying to talk to you and there was a big ball of trash in between us, I'd have a very hard time getting my message across, right? The idea is that what is causing that trash to form? We have to ask this question, what is the trash made of? So what happens is if you look at these brain cells here, you see those clumps, those brown clumps? Those are the trash that don't allow the brain cells to communicate. Somebody has a hard time thinking, communicating, and moving. The important point to remember is those clumps of trash are made of something. They're made of something called amyloid. It's a protein that's normally found in our brain. And what happens is this. Imagine one of your 100 billion brain cells. It needs to communicate to the next brain cell. What you have on one brain cell is like an antenna. And that antenna sends and receives signals. That's normal. For some completely not understood reason, that antenna gets chopped up. Essentially, it's as if a scissors comes along and chops it into little pieces. That protein, that amyloid protein, that receptor, that antenna, happens to be really sticky. It's actually physically gunky. When it gets chopped up, it clumps together. And if we don't clear it out of our brain, it forms the plaques of trash. Okay, so how is something happening in the brain related to diabetes? This is the brand new information. How are these things linked? It basically works like this. How do you feel about keeping your desk organized day in and day out? Not easy, right? What happens when you get busy? Does your desk ever look like this? Or you know somebody like that? It's very easy for that to happen. When we get distracted, things start to accumulate. And that's the key essence of what's happening in the link between these two conditions. I need to tell you one other very important piece of information. Your body is amazing at recycling. It recycles much of you, breaks you apart, and rebuilds you every day. Every second of every day, your body is doing this. Just as if, think about a bunch of cans, we melt them down, we recycle them, and then we build them back up, right? We reuse. Your body does the same exact thing all the time for you. It does this with your proteins. Okay, so you have thousands and thousands of proteins. One protein in your body is insulin, that we talked about, lets the sugar in the cells. Another protein is amyloid. Let me ask you this question. When you break your proteins down, what do you break them into? Anybody know? Amino acids. Amino acids. So the food that you eat, you break it down into amino acids. That's why we need to eat a lot of protein, because then we use those amino acids to build our body, to build proteins. Okay, this is the key point. Insulin, you have to recycle it. The protein that you use to let the sugar in the cells, once you've used it, you break it down into little amino acids, you throw away anything that's broken, you rebuild it, and you use it again. Does that make sense? Essentially, something called an enzyme, and you have thousands of these, is like a little scissors that comes along and chops up the insulin into little pieces for you. So you can reuse it, build it back up for yourself. This is the big insight. It turns out the same enzyme, you have thousands of enzymes, but one of them, its job is not only to chop up insulin, but just happens to be that its job is also to chop up what? Amyloid. So what does that mean? It means that when your body is in balance and everything is working correctly, the same enzyme is responsible for chopping up the protein that causes the plaques, and it's also the same one, the same enzyme, the same scissors that chops up insulin. So what does that mean? We start to put together everything we've talked about. Imagine yourself when you have a job, right? And you have one thing to do or two things to do, and you've got it balanced. But all of a sudden, one of them gets overwhelming. What happens to the other job? It doesn't get done. So this same enzyme, when your body is in balance, gets rid of amyloid for you, which is the plaques in the brain, and gets rid of insulin for you. But let's go back to this. What happens when somebody's developing diabetes or has prediabetes? What is insulin resistance? What did we say happens? When the cells don't hear the knocking, what does your body do? It overproduces what? Insulin. So what your body's trying to protect you, but it's over. So that is called the compensatory hyperinsulin response. That's the technical term for it. But what's really happening here is that scissors, that little thing that was chopping things up and doing its job and balancing both jobs, all of a sudden there's a ton more what? Insulin. And it doesn't have time to do what? To chop up the amyloid. This is a major breakthrough this year in understanding this process. What does that mean? It means that your brain or your body chooses insulin over amyloid, which makes sense. It's more important in the short run for you to make sure the insulin is working right so you're living day to day. And it basically lets the amyloid slide. What happens is when somebody's developing diabetes, they have diabetes, their body is focused on chopping up the insulin and doesn't have time to deal with the amyloid. Okay, and these plaques begin to develop. It's essentially this syndrome. Okay, I know this sounds terrifying and scary. This is fantastic news, and I'll tell you why. For years, for decades, we had no idea what was causing Alzheimer's disease. We were in the dark. You can't fight an enemy if you don't know what the enemy is. Now we know that not all cases of Alzheimer's are rooted in diabetes, but a very significant percentage. What that means is if we look at Alzheimer's, a room full of people that all have Alzheimer's disease, they don't all have the same cause, but a significant percentage of them, the root cause is untreated diabetes. What that means is this is really good news because diabetes treatments work really well. People just need to take them. People need to know about them. Those 90% of people that have prediabetes, they need to know because they could be saving themselves 10 to 20 years to 30 years from now from developing Alzheimer's disease. One of the other big insights of the last few years is these plaques in the brain, when do they start forming? How many years before somebody actually shows a symptom? 30 years before. It's an opportunity to treat these things. This is a huge breakthrough. We can treat these things because treating diabetes is actually really, really effective. This is also the good news. When somebody has diabetes and it's treated effectively, so somebody has diabetes and it's not treated effectively, the risk of developing Alzheimer's disease goes like this. What if you treat their diabetes? It goes right back down.
It's related to the diabetes.
Somebody has diabetes, their risk goes up. If you treat the diabetes, their risk for Alzheimer's in general goes all the way back down. There's even some talk that it might go below other people's risks who don't have diabetes. We'll talk about that a little bit later. What we're realizing is how critical it is to be treating these things decades before. Okay, so any questions at this point? Yes?
My question relates to why, in your opinion, why is 90% of the pre-diabetic people unaware with the amount of blood testing doctors do on an annual basis? Why aren't they comparing it from year to year to say something's going on?
That's a great question. The question was, why aren't doctors on top of prediabetes? And so we're going to talk about a campaign that was actually, of all timing, great timing, was actually announced today, in which the idea is that this has to be a number one priority, that prediabetes has not been taken seriously, and it has to now, based upon this information. Any other questions at this point?
By the
Yes.
way, do doctors, do our GPs believe that statement to be true, that is that important, that they're doing?
Every doctor in the American Medical Association received an email this morning telling them what you're hearing right now. So they should, starting today. Yeah, yes.
I'm curious, it seems so obvious, all the research that's been done about mental issues, that this hasn't been part of a study that's been done before, that they found that such a high percentage of pre-diabetic people have this. Here we're now finding out now, and they've been doing all kinds of studies on the brain and so on. Why did it take so long to focus on this?
For a while we've known about these associations, but they're very hard to tease out. Until we have the mechanism, which is brand new information, then we start to really understand. Because it's very hard to tease out a very complex condition, like Alzheimer's, that has many different roots. And we start to realize that this specific root is a big part of it. Okay, yes?
Mark,
Yeah.
in my family, there's no diabetes, but my father did get it in later years of life.
Mm-hmm.
So what causes that? Is it sometimes doesn't show until you're aged, like in your 70s?
Right, so that can happen. So that it can happen much later in life. It can happen essentially at any point in life. Once either the insulin resistance has reached a point, meaning that the cells no longer hear the knocking, or that something has happened in the pancreas and it's not efficiently releasing enough insulin. Yeah, so it can happen at any point. Okay, we'll take, yes, one more question.
So I go to my doctor and I say, hey, test me for pre-diabetes. So what do you mean? How can I test you for something that is not there yet? So
that the levels to test, that's a great question. To test for prediabetes, there's 3 excellent tests. One of them is called hemoglobin 1AC, and so you'll get that in the notes. And the idea is that it tests to see the amount of blood sugar that is attaching to blood cells in the vessels. And it's used to see that if the levels are too high, meaning there's too much sugar there, the insulin might be dealing with it, but the levels are sneaking up. They're getting higher. They haven't reached the threshold of what we'd call diabetes yet, but that's somebody, and we'll talk about in the next section, is that there's many things we can do to bring somebody back so that they're no longer pre-diabetic. Okay, so how do we treat diabetes now that we realize how critical it is? We've known this for a while, but it's now critical for so many more reasons. Okay, one thing is, and that's the question was just asked, is that people need to know they have diabetes and prediabetes. What are the symptoms of prediabetes? No symptoms. Why is that? Very rarely symptoms, because the insulin in the pancreas is working double time, and it's doing its best to not let you know anything's wrong. The only way to know is by a blood test. It's now, as of this morning, every GP, every general doctor got an email saying this has to be tested, or else there's going to be a serious problem in the next 10 years, the next 20 years. Okay, symptoms of diabetes: increased urination. Sometimes somebody's breath will have like an acetone flavor to it. People can feel tired, lethargic. Many different symptoms that can feel like other things. The gold standard is, again, the blood tests. And there's 3 very good ones. Okay, so The key point in all of this is that for people who are either diabetic or for people who are pre-diabetic or people who don't want to become pre-diabetic, the key point is we want to avoid insulin resistance. We want our cells to reach a point where we don't want our cells to reach a point where they don't hear the knocking. That's the key thing. So how do we do that? Because we've learned that if we intervene, people who are pre-diabetic, we can keep many of them from developing diabetes. We'll talk about those numbers in a second. So we want our cells always to hear the knocking. So how do we do that? So what causes insulin resistance? So there's a long list of things. That's the truth. But there's a couple that really stand out. So excess weight, high blood pressure, cholesterol, triglycerides in the blood, obesity, infection, severe illness, stress, inactivity, genetics, some medications. Some of these are much more common than others, though. And the key ones is that one way, so there's two ways, the first one we'll talk about, to lower insulin resistance, to keep our cells hearing that knock, is to lessen our need for insulin, to not overtax our pancreas so it has to release tons of insulin to our system every day. Now, you might have heard of the glycemic index. We're now moving more to something called the glycemic load. The glycemic index is this idea of take any food, how much sugar is it releasing into your bloodstream, and how fast is it releasing it. The more important question, though, is something called glycemic load, which is the whole meal. How much is the whole meal doing? Because most of us don't eat just one thing for a meal. Okay, so this is a common question. Bananas have sugar, right? They have about 3 teaspoons of sugar. A can of Coke has about 10 teaspoons of sugar. So is 3 bananas the same as 1 can of Coke? Or are these things the same? So there's a lot of books that are written saying just avoid all sugar. Cut all sugar out. We always want to understand that the key thing here is the added sugar. There's a very big difference between a banana and a can of Coke. And the difference is that a banana has been essentially designed over millions of years of evolution so that the sugar is released very slowly into our bloodstream because the sugar is hidden and packed and surrounded by fiber. So the intestines have to break that fiber apart, and then that sugar is slowly released into the bloodstream, and the insulin can handle it. The difference is what happens with a can of Coke. No fiber. It's essentially just like a rush of sugar into the system that the body has to deal with. Another big difference is that a banana has vitamin C, B6, potassium. Vitamin C is an antioxidant for tissue repair, immunity. B6 is energy production, metabolism. Potassium is for heartbeat, muscle function. Can of Coke has none of these things, right? So we have to realize that the sugar, it's not just about the sugar. And also, do we classify fruit as added sugar? No, fruit is not added sugar. Added sugar is very different. We always want to now really think about how much added sugar are we getting. Some of these are really, really obvious. The things that are so delicious, right? The cookies, the cakes, the candy, those are obvious that they're loaded with, there's a ton of added sugar. But we have to be aware that there's a lot of hidden sugar in our food. And the FDA just about a week ago made a big announcement that they want people to know about all the hidden sugar that's in their food and that to understand how much the average American is consuming a day. So the average American, how much sugar do you think they consume a day? 22 teaspoons a day of added sugar. That's not counting fruit, naturally occurring sugar. This is added on top of. This is much more, almost double or 3 times the daily limit of 6 teaspoons for women and 9 for men. The FDA made an announcement that 12 should really be the cap for anybody. Yes?
How many grams is that?
About 5. So the about 5 teaspoons is a gram. Okay. So I made it here. 1 teaspoon is about 5. 1 teaspoon is about 5 grams. That's the calculation. So I actually did them here for you. Okay. So there's a lot of hidden sugar. There's a lot of products that they spend hundreds of millions of dollars advertising these things to sound like they're healthy, and they're jam-packed with sugar, added sugar. So those granola bars, the yogurt that has the fruit on the bottom that's not really fruit anymore, and the cereals that are marketed as healthy. So those things are actually loaded with quite a bit of sugar. The other thing, so really there's a lot of hidden sugar that we have to be aware of. The other thing is, does anybody know about the fat-free trick? The fat-free trick is take out the fat, put what in instead? Load it up with sugar. So just to show you, Nesquik fat-free chocolate milk is fat-free, but it has 10 teaspoons of sugar added in. Yoplait original 99% fat-free yogurt has 31 grams, 6 teaspoons of sugar. Skinny Cow low-fat ice cream cone, 6 teaspoons of sugar. And these teas, like Snapple teas, they are loaded with added sugar, right? So this has 40 to 50 grams of about 10 teaspoons of added sugar. These things are marketed as health food, and they're jam-packed with added sugar. Okay, so one key thing that we haven't talked about is when we have too much sugar in our blood, what do? We take that sugar and what do we do with it? We store it as fat, right? Basically, we send it to our liver, and our liver basically starts putting on weight for us. Okay, so the other thing is, the first thing is we want to decrease the amount of added sugar in our life so that we're not overwhelming our insulin system. The second thing is we want to keep our cells so that they constantly hear the knocking, and they're not getting essentially deaf to the knocking sound of the insulin. So how do we do that? Exercise. Right, so one of the big things is exercise is the best thing we know of to keep the cells able to hear the knocking. It turns out that it actually makes perfect sense. But there's more to this. What do you think is better? Somebody who's sitting all day and goes to the gym and works out really hard for an hour and then goes back to sitting at their desk and sits most of the day but does a really, really intense workout for even an hour or 2 hours, versus somebody who has what we would call light physical activity throughout the day and doesn't even have an intense workout. Which person do you think has more insulin sensitivity, meaning their cells hear the knocking much better? The light activity throughout the day. This has been a big research project that really wrapped up last year, looked at thousands of people, and what they found is the same thing over and over again. It turns out that even though we might not think it, but things like this, just taking the stairs, standing, taking a break and standing, walking to work instead of driving one day, walking to the grocery store, these little tiny things, they might not seem strenuous to us, but what happens is they make our cells really good at letting sugar in. Why is that? Because in order to do all these things, what do we have to do? Let sugar in. So if we're doing these things throughout the day, we're essentially training our cells and telling them you've got to stay good at hearing the knocking so that the sugar can come in and we can actually move our muscles. As opposed to sitting for most of the day, getting out and working out really hard, and then going back to sitting. That doesn't seem to keep the muscles as attuned to hearing the knock. So we start to realize that these little things make a big difference. It's really light physical activity that keeps the cells able to hear the knocking sound. Okay. This study just recently came out. It was a big study done in Finland and in the United States. What they found is that if you take people who are pre-diabetic, they're on their way to getting diabetes, and you change their diet, you cut their added sugar, you put them on general healthy eating plans, not even super restrictive, just cut out added sugar, and you have them do light exercise, be active throughout the day, people who have pre-diabetes lower their chance of developing diabetes by almost 60%. That's a huge drop. 60% just by those two things without medication. Okay. Have you seen these studies that are just starting to come out? Aerobic exercise improves function for brain function for people with prediabetes. It's all part of the same mechanism. The idea is that when people get their heart rate up, they do some light activity. Some people with prediabetes will often complain after they've been diagnosed. They have trouble remembering things. They have trouble thinking clearly. And that's because that trash is starting to accumulate in the brain. But once they start to introduce light activity, what happens? The cells get more receptive to letting the glucose in. The scissors can now do their job and balance the amyloid with the insulin. Does that make sense? Okay, yes?
But the damage that's already been done stays there.
So we're going to talk about that at the end. We'll talk about that. Okay. So what we really realize is how important it is for this need for balance, that every aspect of our life is the link between enzymes being able to take care of their jobs, the amyloid and the insulin. Okay. So big questions being asked, how much of Alzheimer's and dementia is actually preventable by diet and exercise? It's believed to be quite a significant amount. But what about medications? This is something that really needs to get out there. Some people, beyond diet and exercise, they need medication. Either they can't stick to a diet plan, or that they're having trouble with exercising for a variety of reasons. Do we have medications that are effective? We have a medication called metformin, and it works in two ways. It actually limits the amount of sugar that gets released into the blood, and actually keeps the muscles able to hear the knocking better. Now, these studies have shown that you put people who are pre-diabetic, you put them on metformin, and their risk of developing diabetes drops by 30%. Now, not as high as what? Diet and exercise was actually higher, but 30% is significant. So UCLA did a study and they asked this question. What percentage of people in this country who have prediabetes, their doctors have told them they have prediabetes, have been put on metformin, which could keep them from developing diabetes? What percentage do you think? 3.7%. This is a serious, serious problem. And the word has to get out. Patients and doctors need to know about this, that there is a medication that can help people not transition from prediabetes to diabetes. Yes?
What's the benchmark that brings you to pre-diabetes?
So there's a specific number that I can email you. So there's, on those hemoglobin A1C tests, there's a certain number. Every blood test is slightly different, but there's a certain number where you're basically in what they would call the danger zone of passing the threshold. Yes?
Once you start taking metformin, though, didn't you already, in terms of insurance reimbursements, you've already transitioned to being diabetic? I think so.
In terms of insurance, I don't know the insurance things. I know this medication is not that expensive.
I think there's no such diagnosis as prediabetes with metformin. At least there wasn't until this morning.
Okay, so I know that this is a big push to get this medication to people. That we have 10 years of research, 15 years of research. This medication is critical. It can help people. Yes?
How many people does it work on? Because I've heard some people say they take it and it doesn't work for them.
So about 30% it works for. The diet and exercise works for is 60%.
Yeah.
And then there's other things too, but these are two of the big ones that need to be talked about.
So 30% of the people that take metformin
don't
effective.
protects them from going from prediabetes to diabetes, right? If you take metformin and you have diet and exercise, it's even higher than 60%. Okay. Yes.
As my blood sugar levels were being tested and rising, therefore I was pre-diabetic, and my doctor was sensitive to it, he prescribed to me Genovia.
Mm-hmm.
Why is Genovia not being talked about?
Oh, there's just too many.
When I passed the bar to become diabetic, he added metformin to it.
Okay, that's a great question. Let's do that one at the end. But great question. Great question. Okay, so why is this not being prescribed? That's a big question. The answer is we don't know, but prediabetes hasn't been taken as seriously as it should be, and it really needs to be, and that's all changing, fortunately. Okay, we've talked a lot about sleep, so we won't go too far into it, but I want to tell you two things. Sleep is critical to keep us from developing diabetes for two reasons. Why is that? If we don't sleep enough, right, so the first thing is there's a clock in our brain that controls when we sleep and when we're awake. If that clock isn't functioning correctly, we just have learned that clock also controls our pancreas. So if that clock is thrown off, it sets off the insulin isn't released properly. So sleeping effectively actually keeps us from developing diabetes, can protect us and lower our risk. The second thing is, research we've talked about quite a bit about, is that what happens every night when we sleep? What happens to our brain? It shrinks down to what? 60% of its size, and it squeezes out all the trash. Fluid comes up from our spinal cord and washes all that trash away. So every night we have an opportunity to wash that trash away out of our brain. So sleep is a key part of keeping our brain essentially clean, washing it out. Yes?
But what happens if one takes sleeping pills? Are you getting the same benefit?
So that's a big question, is that if we're not passing through if the sleeping pills are impacting our ability to pass through the sleep cycle effectively, the concern is that we're not getting the benefit of the brainwash. Yeah, so. Okay, so we're going to wrap up today and then have time for as many questions as you like. But new info and lots of hope. I want to show you just some research that's come out this month that's really exciting for diabetes. Just this month, a group of scientists screened 10,000 potential drugs and found one called Harmon. It's now in clinical trials. And the idea is that this drug can cause the pancreas to regrow the specific cells that make insulin. The second thing is identifying the dimmer switch for diabetes. Another group of scientists just in the last month identified a sequence of proteins that work together that are responsible for turning the insulin on and turning the insulin off within the cells. They're actually able to control the release of this insulin as if it's a dimmer switch on a light bulb, meaning they can turn it up and turn it down by introducing other specific proteins. Very, very hopeful for treatments of the future. We're starting to see that people are now being treated with diabetes with nasal sprays, also with gels, patches. All these things are coming. They're either in development or they're very closely on their way, that people won't have to do injections, that there's other ways to regulate these systems. Another thing is, one of the most exciting areas about this is this field is coming together in a very unique way. What about this question? You take people who have diabetes or prediabetes, and you put them on medications, and there's a variety of them, that help them with their diabetes. There seems to be this side effect that they improve their brain function. It is actually protecting their brain. Based upon everything we've talked about, you put the diabetes in control, you get increased protection for the brain. There's some studies that are starting this year. They're going to start asking this question. Can we take people who are at a high risk of Alzheimer's disease because of something that in their family or something that has happened in their life? Can we take them even if they're not diabetics, and can we put them on medication for diabetes to help them and lower their risk of actually developing Alzheimer's? We're going to be using diabetes drugs to protect people from developing Alzheimer's who don't even have diabetes. Now, how do you think those medications are going to be delivered to the brain? It's there in the picture. Nasal sprays. Not injections, nasal sprays, because we need to get that medication directly to the brain, and we don't want it systematically going through the body. So the future is very exciting. As we understand these things, we're going to be able to treat people who don't even have diabetes and protect them from Alzheimer's. The sum up for today, and I wanted to leave time for questions, is we have to be aware that we actually live in a world that sets us up for diabetes quite a bit. We have a tendency to sit at work a lot. There's a lot of options for food that are loaded with sugar, even hidden sugar. We're tricked by marketing. But in this field, there's a lot of really great news, because it turns out that these little changes make a big impact. That just by cutting added sugar, by increasing our activity, it just can be light activity, and we have the science to prove it, it lowers our risk of developing diabetes. It keeps people who are pre-diabetic from developing diabetes. And we're starting to realize that what's happening there is essentially we are causing a domino effect from not happening, right? That this is a chain of events. And if we can protect people and treat them for diabetes, we can save a lot of people from developing Alzheimer's disease. Okay, just today, as I mentioned, this email went out to every doctor in the country. There's a new website called doihaveprediabetes.org. There's a very good chance that starting today, you're going to be inundated with commercials about diabetes. And that's because the American Diabetes Association, the CDC, and the AMA, you'll start to notice TV is going to be flooded with them. They've partnered together with this campaign, realizing this information has to get out. We have to get people to, pretty much everybody has to figure out, do they have prediabetes or do they not? And if they do, to enter into a program or take the steps so that they don't eventually develop diabetes. Okay, the CDC actually has a whole guideline based upon those two studies we talked about, the Finland study, which they basically replicate that study, put people on those diets, those light exercise programs, and they're available all throughout Los Angeles. So if people want to take it a step further, your doctor should be able to point you in that direction based upon this information that was sent to them today. Okay, so tremendous hope. We look at these diseases, especially like Alzheimer's, multiple causes, but we're starting to take a big chunk of a disease like Alzheimer's, understand its root, and have a way to effectively treat it. Okay, I hope you enjoyed today.